So as I said, spread spectrum is a method used for bandwidth utilization. So this is the second method. So this spread spectrum, which is used for the bandwidth utilization, and mainly it is used for the wireless connection like LANs and WANs, local area networks and wide area networks. Okay, and then here, as we discussed in multiplexing, where we combine several sources, right, to achieve, higher bandwidth, or you can say to have a bandwidth efficiency, we followed multiplexing. But here also in spread spectrum also, we combine signals from different sources, okay, to fit into a larger bandwidth link, but by following some other methods. Fine. So here, as I said, it is used for the wireless application, and we all know that wireless application use air as medium for the communication, right? The medium used for the communication is air, right? So when many applications try to use, if as we know, whatever the applications we are using nowadays are all wireless, isn't it? So many application has to share this medium, that is medium is air here. So if that is the case, there may be chance of interception, okay, and also jamming of the network, and also there may be a intruder for the data that we transmit over the transmission medium. So since it is a wireless, these are all the problems that we can face. Okay, there may be interception by an eavesdropper, and also there may be jamming of the network, or there may be a intruder who may listen the data that we transmit over the medium, that is air here. Okay, to see, there are military applications which are used, which are wireless, right? So we all know the data that is shared by the military application has to be kept as a very secret, and it is, it is very secret data, right? It should not be shared with anyone. So since wireless applications are used with respect to military, proper security has to be provided for the data, right? So to achieve that, here the spectrum is used. Okay, so let's consider, if each station, that means each source has a it has a bandwidth of b. Okay, so one station has a bandwidth, or the required bandwidth of one source is b, then for which we apply spread spectrum, which expands this bandwidth b into BSS, where BSS is greater than the b. Okay, so what does it mean? We are expanding the bandwidth that is considered for the input source, okay, by following spread spectrum. Okay, so since this expanded bandwidth, that is BSS, okay, so allows the source to wrap its message in a protective envelope for a more secure transmission. So this is done to provide a secure transmission. So do remember, when I say spread spectrum, it is a technique used for bandwidth utilization. I mean, to have a better bandwidth efficiency, and also to overcome the problem of interception, jamming, and also intruder. Okay, to solve this problem, we use spread spectrum, where the required bandwidth of the input source is increased, you can say, or you can say you are going to expand it, or you are going to spread out to BSS, where this BSS is always greater than the bandwidth required for the input source. Okay, so let's see the diagram, then you will understand it. Okay, so here I'll directly go to the diagram here. As you can see diagram here, this is the what signal which has a bandwidth of b, okay, which is generated at the source side. Okay, and then this is signal which has the bandwidth B undergoes spreading process. After undergoing this process, the output of this process will be BSS. That means the bandwidth has been expanded here. Okay, what is the spreading process? Which is nothing but it is a spreading code or some technique followed to expand the bandwidth of the input line or the input source. Okay, this is how it works. And this SPED spectrum works on two principles, that is bandwidth allocated to each station or each source uh, to be larger than what is needed. Okay, so that means you have to spread out, right? So for that, we are adding extra bandwidth, or you can say we are allowing to use redundancy. See, you have to increase the bandwidth here, or you have to expand the bandwidth here, right? So to do that, you have to add some redundancy data. So that is nothing but whatever the redundancy I mentioned here. So redundancy means with respect to this scenario is inclusion of extra component. So that will help you to expand the bandwidth. Okay. And second principle is that the expanding of the original bandwidth B to the bandwidth BSS must be done by a process that is independent of the original signal. So there should not be any dependent with respect to the original signal. Or you can say the spreading process. This is the spreading process occurs after the signal is created by the source. So as I explained this diagram, first the source will generate the signal. Okay, after generating, it is passed to the spreading process. After undergoing spreading process, it will expand the bandwidth to BSS. So these are the two principles followed by spread spectrum. Okay, now next thing is what? How to perform this SPED spectrum. That means how you can obtain or how you can apply this uh, spreading process. Okay, so this can be done by following two techniques, that is FHSS, another one is DSSS. FHSS is frequency hopping spread spectrum. Okay, and DSSS is nothing but direct sequence spread spectrum. Okay, these are the two techniques used, and this is very important topic. And nowadays IoT, that is Internet of Things, it is everywhere in the market, right? It is in boom, right, in the market. So where to implement this IoT, that is Internet of Things technology, these all methods are used. See, whatever things you are studying in DC, data communication, that is everything is included in Internet of Things. So when you take up the course like IoT or a course online or offline, you will come across of all this. You're going to see the inclusion of these techniques in IoT technology. Okay, so while studying the subjects, any subject you take, you have to understand the concept properly. Okay, only for the mark's sake, don't study. That may be the primary thing here when you need to get a degree, but I suggest that you understand the topic so that whatever happening in the market, you can relate with that, what the content you have studied in the class. Okay, so let's see the first one, that is frequency hopping spread spectrum. So this frequency, in short, you call it as FHSS, right? So here in this method, as you know, we are expanding the bandwidth of the input source signal, right? So this method uses M different carrier frequencies that are modulated by the source signal. Okay, so here you have to remember the source signal, okay, modulates m different carrier frequencies. So we have studied what is carrier frequencies, right? The base signal of the input, right? So that is carrier signals, right? So here, uh, see, if I just tell you these points, you will not understand, but I'll just read out the given point here, then I'll show you a video, then you will understand it better. Okay. So at any point of time, the signal modulates one carrier frequency. It says this method uses m different carrier frequencies, right? But with respect to this technique, at a given point of time, the signal, that is source signal, modulates one carrier frequency at a time. At the next moment, it modulates another carrier frequency. Okay, so in total, it will modulates m carrier frequencies. Okay, so and then after applying this method, it is what the bandwidth is expanded to BFHSS from the bandwidth B. So what it says, the source signal bandwidth is B. After applying this technique, you will get the expanded bandwidth, that is BFHSS, that is bandwidth expanded with the help of frequency hopping spread spectrum. Okay, this is about the introduction. Now this is how what model here I said the source signal modulates the carrier frequency, right? This is done with the help of this procedure where original signals take the carrier frequency from the frequency synthesizer, and then it will generate spread signal. What is spread signal? Where the bandwidth has been expanded compared to the original signal. Okay, now how do we generate carrier frequency with the help of frequency synthesizer? This is done by using pseudo random code generator and the frequency table. Okay, so this is the overview of how FHSS works. Fine. Now I'll just explain how actually this method works. Okay. So here, what is the thing given here? Pseudo random code generator, right? Actually, this is called as PN, or you can say pseudo random noise. Please do concentrate. This pseudo random code generator is called as pseudo random noise. In short, you can call it as PN. Okay. This generator generates k-bit pattern for every hopping period. So we'll see what is hopping period in the next slide. Okay. So as of now, you remember pseudo random code generator. This generates k-bit pattern for every hopping period, that is th. Now you see this generator will generate k-bit patterns. That is, you can see here the digits are written here. This is what 3, actually k here 3, value is 3 here. 0 0 101 111 001 000 010 110 011 100. So this generator, the pseudo random code generator, generates this k-bit pattern. So when I say pseudo random, what it means? The numbers are generated randomly. Okay, no particular pattern is followed if I say random code generator. Okay, so this generates this k-bit pattern. Okay, and when the first bit pattern is considered, this is, see, you can see for this pattern the frequency table is created. You can see here, this is the frequency table. So when this pattern is considered, you can see here 8 values are considered: 1 2 3 4 5 6 7 8. Okay, from 0 to 7. If the k-bit pattern is 0 0 0, then the frequency considered is 200 kilohertz. If I use 111, then the respective frequency is 900 kilohertz. Okay, the first bit generated by this code generator is 100, so its respective frequency is 700 kilohertz. So this is the first hop frequency given to this frequency synthesizer. This synthesizer generates first carrier frequency that is given to the modulator. This original signal modulates that carrier frequency and generates the spread signal. Okay, I hope you understood. I'll just summarize what I explained now. Okay, this original signal modulates the carrier signal generated by the frequency synthesizer, and it generates a spread signal where bandwidth has been expanded. Now, as I said, the output of this frequency synthesizer is carrier frequency, right? How it is generated? Basically, the pseudo random code generator, or you can say pseudo random noise, it creates k bit pattern for every hopping period. Okay, so this when it is generated, the frequency table also created for the pattern, for this pattern. Okay, then when a particular bit is generated by this code generator, the respective frequency in the frequency table is referred, and that frequency, that first hop frequency, is given to the frequency synthesizer. This generates carrier signal and it is given to the modulator, where original signal modulates that carrier frequency and generates spread signal. Okay, this is how the frequency hopping spread spectrum is uh, implemented. So with respect to this, let's see a video, then you will understand in a more clear way. Okay, just listen to this. Listen to this. Okay. So yeah. Yeah, one second, I'll replay it. Yeah, uh, yeah, that is about FHSS. I hope this video give you a clear picture of frequency hopping spread spectrum. See, now you got to know what is hopping, right? The channel is divided into multiple frequencies as explained in the video, and when you send the data, it passes through different frequency channels. It doesn't follow only one channel. It follows different frequency channels, right? So and it generates a particular pattern that we call it as k-bit pattern. Okay, so when this pattern is followed, the respective frequency is referred and it is given to the where frequency synthesizer, and this gives you the carrier frequency. Okay, I hope this video is clear to everyone. So that is what explained in this diagram as well. Okay, now yeah. So whatever I explained, I just listed out in the slide here. Okay. So that is about FHSS. Now we'll move on to DSS. We'll move on to DSSS, which is direct sequence spread spectrum. Again, direct sequence spread spectrum. It is also used to expand the bandwidth of the original signal. Okay, but it follows some different method. Here in DSS, we replace each data bit. Do remember in DSS, the data will be in the form of, as I said, this is for the digital data, right? So, this is for the data where if I consider the data bit, I just want to send over the network or the transmission link. If it is 1 bit data, then to which I'm adding spreading code as n bits. See, I'll just repeat because you have to expand the bandwidth here, right? So if I need to send 1 bit of data over the transmission link, then with the help of spread spectrum, under which I'm using direct sequence spread spectrum, using this, I'm expanding the bandwidth of this input. So in that case, the spreading code what I'm adding to the input data is n bits. Okay, for 1 bit, I'm adding spreading code as n bits. Okay, so this we call it as chips here. For example, see here, we replace each, say, data in input data is here 1 bit, okay, with n bits. Why I'm doing so? Because I have to expand the bandwidth. That is, which is nothing but the spreading code here. In other words, you can say each bit is assigned a code of 11 bits. So this we call it as chips here. Okay, so where chip rate is 11 times that of the input data bit. Here you can see, here the chips are generated with the help of chips generator, which is given to the modulator where original signal modulates this and generates spread signal. Okay, this is how the direct sequence spread spectrum works. Fine. Now we'll see a video with respect to direct sequence spectrum where you will understand how actually it works. Okay, so let me play that video. Yeah. See, I don't know. I don't know. The volume is not. Okay. See, I have what highlighted this captions. Just follow that. I don't know. The volume is not available. Oh, yeah. Yeah. Just listen to this explanation. Yeah, that is all about DSSS. Okay, so here in this you can see this is the data. One second, this is the data that you want to send it. Okay, so this is here expanded. The bandwidth need to be expanded, right? For this, the chip generator where chips are added for this data. So to send 1 bit of data, we are adding these many, these chips to this data, and then we are generating the transmitted signal. Okay, that is about DSSS. Okay, that's all with respect to SPED spectrum.